Okay, today we're going to talk about Z transform and we're going to talk about unit circle. So I'm studying for the breadth exam at UNCC, and one of the questions I'm looking at is the system with Z transform H of Z equaling 25 times Z squared minus 24 over Z times 20Z plus 1 has a regions of convergence greater than 1 over 20 would be best described as A, low pass, B, band stop, C, band pass, or D, high pass. So when we look at a problem like this, one of the things we need to understand is what is a low pass, what is a band pass, what is a band stop, and what is a high pass. So if we look at this, we need to understand all four. But before we get to that point, one of the things we need to look at is what are the poles for H of Z. So poles are, you look at your denominator and you evaluate what Z needs to be in order for Z times 20Z plus 1 to equal 0. So we know that if Z equals 0, we get 0. We also know that if Z is equal to negative 1 over 20, we also get 0. The second thing we need to look at are our zeros. And how do you determine what a 0 is? You look at the numerator and you set it equal to 0. So 24 divided by 25, and if we take the square root of that, plus or minus, we get that our Z will equal it's going to be plus or minus 0.97. Now, when you plot this on a unit circle, don't forget that the y-axis is your imaginary and your real axis is the x-axis. Unit circles are graphed based on the y-axis containing negative j as its high point and positive j as its high point and negative j as its low point. And for the real axis, we're going to have negative 1 for our low point and 1 for our high point. Now, we can also look at this as when the angle, so we can say when omega is equal to 0, we have 1 for our unit circle. When omega is equal to 9 at 90 degrees, when we have an angle of 90 degrees, it will equal positive j. When we have an angle of 180, we'll get negative 1 for our unit circle. And when we look at negative 270, we'll get negative j. So if we plot our poles, which were at 0 and at negative 1 over 20, and if we plot our zeros, which was at plus or minus 0.97, we get a unit circle that looks like this. So as you can see, we have drawn our poles as x, and we have drawn our zeros as circles that look like a 0. And if we look at this system, then what we can start looking at is what does a band pass look like? So we see that a band pass has zeros, and it also has some x's between the zeros. We also see a band stop, which has a 0 in the center, and it has x's on the left and right of that 0. Now, whenever you see an X, what you can think of is something like a pole. So here I have an example of a 4D drawing where you can see when you have a pole and then a 0, and then a pole and then a 0, you see that at our poles we have these impulse looking 4D diagrams. So in order for us to get something that looks like a low pass, we need to have our system do something like this and then go up and go straight. So in order for us to have this increase, so as we go straight and then it goes up, we need to have zeros and then an impulse. So for our system on a unit circle, you can imagine that it's everywhere there are zeros. The impulses are what defines your system. So if we're looking for a 0, then we go up and we go straight and then we go down and we go back to 0. We can think of this system as being like this. So we started off low with the zeros, then we went up, we stayed up, then we had a 0. And if we think about our system like that, what does this look like? A band pass, correct. That's all. I hope you have a great day. I hope you guys learned something.